Now watch the ball as Anya throws it upwards. There again we have a motion occurring, but of a different kind. See the ball travel all the way up, reaching a maximum height, and after a point it comes right back down. The equation of motion of a body that is thrown upward changes again. In this case, a force is used to throw it upwards, and so there is an initial velocity, u in existence. Since the ball moves in opposite direction with respect to gravity, g is negative here. Hence, the equations of motion are as shown here. So, v is equal to u plus or minus gt becomes v is equal to u minus gt. H is equal to ut plus or minus gt square divided by 2 becomes h is equal to ut minus gt square divided by 2. And v square minus u square is equal to plus or minus 2gh becomes v square minus u square is equal to minus 2gh. Wow! Look at how high the ball went. We can calculate the maximum height reached by the ball using this equation here. In this equation, the initial velocity is represented by u. The g here is negative as the ball moves in the opposite direction to that of gravity. As the ball goes up, you notice that its velocity slowly decreases, and at the maximum height it becomes 0. So there we get the equation required to calculate the maximum height. V square minus u square is equal to minus 2gh. So u square is equal to 2gh. H is equal to u square divided by 2g. The next amazing thing that we can find using the equations of motion is to calculate the time taken by ball to reach the maximum height. This time is called as the time of ascent. We take this equation of motion. V is equal to u minus gt. We already know that final velocity is 0 and g is negative. So time of ascent t is using this equation that can be calculated as v is equal to u minus gt. 0 is equal to u minus gt. gt is equal to u. So t is equal to u divided by g. Time of ascent is equal to u divided by g. T is directly proportional to initial velocity. Now we can also find the time taken by the ball to come down after it reaches the maximum height. This is known as the time of descent. To calculate this, we can use this equation. H is equal to ut plus 1 by 2 at square. Initial velocity u is equal to 0. G is positive. H is equal to ut plus gt square divided by 2. So H is equal to gt square divided by 2. T square is equal to 2h divided by g. T is equal to square root of 2h divided by g. Since we have already calculated maximum height, we replace the value in this equation. Now, maximum height h is equal to u square divided by 2g. T is equal to square root 2u square divided by 2g square. T is equal to u by g. Time of descent is equal to u by g. It is interesting to note that the time of descent and ascent are always equal for bodies moving under gravity. Time of flight means how long the body was in air, and therefore it is the addition of the two values, that is, time of ascent and time of descent. So, time of flight is equal to u divided by g plus u divided by g is equal to 2u divided by g. We have calculated the maximum height reached when it is thrown upwards. H is equal to u square divided by 2g. From that equation, we can also calculate the initial velocity of the body. Now, maximum height h is equal to u square divided by 2g. So, initial velocity u is equal to root 2gh. We have also calculated the velocity of a freely falling body. This velocity is the value obtained when the body reaches the ground, that is, the final velocity. Velocity of a freely falling body v is equal to root 2gh. In essence, we can say that at any point of flight, the upward velocity at any point is equal to its downward velocity. In this lesson, we saw how the equations of motion alter for a freely falling body as well as for a body thrown upwards. Wasn't this an interesting lesson? From now, when you throw a body up in the air, you will recall all these concepts.